Good afternoon, everyone. Welcome to JuiceFS Office Hour, episode number 8. So today we are thrilled to have our co-founder, Surey, to talk about how to choosing file systems for the AI payloads, either is training, referencing, or even running AI agents. Before we dive into this exciting topic, I would like to give you a briefing of our community updates. So for the community edition, we have a new release which have enhancement of Windows support, as well as the optimized the bench clone performance. So for technical details, you can visit our GitHub repo, and there's a technical dive of the in the release notes. So make sure you check out the new release of Community Edition. And for CSI driver, I think the more and more customers are using JuiceFS client in Kubernetes. And we have customers have thousands of Mount pods across multiple Kubernetes clusters running JuiceFS client. And there's real lessons learned from those customers. And in this new release of CSI driver, we actually pull those lessons learned into our open source CSI driver code base. So for instance, we optimize the way we request the Kubernetes API using caching, so there's less request. And also we introduce the configurable workload setting, which could speed up or scan down the processing capabilities, as well as an enhancement of the CSI dashboard. Maybe in the follow-up session, we could have a walkthrough of all these new capabilities over there. In fact, if you guys follow our office hour, the last 3 episodes are dedicated for the CSI. It covers the basic consent, installation, troubleshooting, and performance tuning of the CSI drivers. So make sure if you are planning to using JuiceFS in the Kubernetes, make sure you visit those recordings. It's in our YouTube channel. Okay, so without further ado, let's welcome our co-founder, Surey. It's yours.
Hi. Yeah. Hi, hello. Hello, everyone. I'm Risu, co-founder of JuiceFS. And welcome to our office hour number 8. I will spend about 20 minutes. Very important topic, how to choose cloud file storage for AI workloads. And first, I want to make one thing clear. It's not a talk about which product is the single best choice. This is no one answer for everyone. Instead, we'll look at 2 things: the needs of your business and the real feature of different storage products. When you stand both sides, it's become much easier to choose the right storage for your own system. And today, we'll look at small 3 main product groups. First, the cloud managed file system. This include Amazon EFS, GCP file store, Azure files, and OCI file storage. Second is a high-performance file storage. All 4 major US cloud provider offer managed Lustre in this category, and because they all use Lustre, so these products have many similar strengths and limits. Third is a third-party products. Here we are looking at JuiceFS, Alluxio, and Vika. We'll talk about this product in general, but most of today's discussion will focus on AI workloads. Now let's look at cloud managed file systems. This group includes Amazon EFS, GCP file store, Azure files, and OCI file storage. What are these products made for? In simple words, they are standard file server in the cloud. Most of them use NFS, and Azure mainly use SMB. Because they are standard protocol, so they fit well into existing software system. You don't need to install any special client. You also do not need to manage a customer kernel module, and the cloud provider can upgrade this server side without changing your application side. These products are also used with familiar security modes, such as the UID and the GID, Kerberos, and Active Directories. This is why they are attractive for enterprise moving from on-prem data center to the cloud. The migration paths feel familiar and safe. So where do these products work well? They work very well for traditional shared file use cases. For example, department share folders, web upload directories, or general file service. This use case usually have one thing in common. Everything is under control, including the total data size, file count, number of clients, and the I/O loads are all limited. But as we will see next, this traditional file system are usually not a good fit for AI workloads. Yeah, so why these standard cloud file systems are not a good fit for AI? To answer that, we need to look at the nature of AI workloads. They are extreme. First, the data size is huge. We are not talking about a few terabytes. We are talking from hundreds of terabytes to hundreds of petabytes sometimes. Second, the file count is also huge. You may see hundreds of millions of files, or even hundreds of billions. We have seen this in fields like autonomous driving and biotech. Third, the AI workloads are very high concurrency in traditional IT system. Maybe a dozen of clients connect to a file server. In AI training, the number can grow from hundreds of tens of thousands to tens of thousands. In some short jobs, the peak can even reach hundreds of thousands of connections. Another challenge is file type and L pattern. AI data often include many small files. The access pattern is also complex and mixed. This creates constant pressure on metadata operation. And finally, AI workloads need very high throughput. A single client may need several gigabytes per second. The full cluster may need hundreds of gigabytes per second, or even terabytes per second. And here, I mean bytes, not bits. Now, let's compare those AI needs with the limits of standard cloud files. I will not mention a few examples here, but not a full list. First, Amazon EFS has maximum throughput limits of 1,500 megabytes per second for one file system. GCP file store has a maximum file system size of 100 terabytes, and Azure Files has a large limit of 35,000 ILPS. OCI file storage assign performance by month target, so user need to plan your system carefully, apply for quotas, and sometimes make a billing commitments to secure the performance they need. And these limits show a clear problem. Once AI load become large and aggressive, it quickly hits these settings. And traditional cloud file storage cannot keep up. And this is why the major cloud provider introduced another storage tier, managed cluster. But why Did all four major clouds choose managed cluster? This leads to an interesting question. But the answer is simple. Lustre is one of the most widely used and most proven open source parallel file system in the world. It has been used and tested in HPC environments for more than 20 years. Each cloud provider describes a little differently. GCP says it's managed Lustre based on DDNX scalar, and AWS says FSX for Lustre is based on Lustre open source project. And Azure says its service is built on open source Lustre technology. OCI also say the service is based on Lustre, but it's very likely based on the open source version as well. So by choosing Lustre, all of them get a major parallel file system design that can handle large-scale workloads. And let's look at the advantage of managed Lustre. Across all four cloud providers, the common benefits are clear. Managed Lustre gives you much higher throughput. It gives you much higher LPS and give you full POSIX compatibility. That POSIX support is very important for many existing tools, script, and data pipeline. And at the same time, each cloud provider has added its own feature. AWS has the strongest S3 integration today, and GCP clear position managed Lustre for AI training. It offers strong performance up to 1 terabyte per second of throughput and sub-millisecond latency, and up to 8 petabyte of capacity. And Azure can map data from Azure Blob into Lustre with lazy load. Is very useful and provide up to 500 megabytes per second per terabyte. And OCI offer a high performance profile for 1000 megabytes per second per terabyte. It also supports two-way synchronized with object storage, but this synchronization is not meant for constant real-time updates, so you better to schedule batch import and export. Yeah, managed Lustre is powerful, but it also have some important limits. And these limits can affect your AI storage design in a big way. So let's start with AWS. AWS Lustre run in a single AZ. So if you compute is in another AZ, you will pay cross AZ network fee in both directions. So network design matters a lot. Also, if your workload has many small files, hot directories, highway metadata pressure, AWS Lustre might become a bottleneck. Of course, you can buy extra metadata or LPS, but there is a catch. After you scale metadata LPS up, you cannot scale it back down. If you later want to reduce cost, you have to build a new file system and migrate your data. Now, GCP managed Lustre is also in single AZ, and Google also doesn't recommend it for inference serving. Also, with the sync with the GCS, only one transfer operation can run at a time for each file system. You cannot scale up the concurrency. And Azure's Lustre CS driver is still limited and is only support AKS and Ubuntu US. Or it can load data from Blob on demand, but the setup is careful planning. Later adjustment is not very flexible. Now, the last is OCI. OCI has a strict size limited. Each file system, the minimum capacity is 31 terabytes, but the maximum is only 200 terabytes. Unlike Azure, OS support is limited OCI mainly support Ubuntu 22.04 and Oracle Linux 8. This is also one shared limitation across all 4 clouds. Elastic performance is tied to provision capacity. That means even if you do not need to more storage space, but you may still have to buy more capacity just to get more throughput. And for AI workloads, that can become very expensive. Okay, because of this limit, many teams also look at third-party storage products. Let's talk about 2 common names first, Vika and Alluxio. First, Vika is often very strong performance, but in the cloud is usually built on block storage like EBS. That means the base resource cost is often much higher than using local disk in your own data center. And Vika also use a kernel mode client, so your team need to manage more things, include maintenance, OS compatibility, and kernel tuning. Like last year, Vika also needs care for capacity planning in advance. It cannot scale up and down in truly elastic way. Now, Alluxio is important to say this clearly. Alluxio is not really a file system. It's a cache and acceleration layer on top of object storage. The biggest advantage is transparency. You can put it on top of your current object storage without moving your data. But the trade-off is also clear. It doesn't provide full POSIX compatibility. For pure AI training, which is most read-only, Alluxio can work well. But in data preparation and data processing, the tool and the frameworks usually need a strong POSIX behavior and strong random read and write. In those stages, Alluxio becomes much more limited. Now, let's move to JuiceFS. How does JuiceFS solve the problem we discussed? The case in the architecture, JuiceFS is built on top of standard cloud object storage. At the same time, it's use an independent metadata engine. User connect through a Fuse client. The client is also use transparent cache. So the design brings several important benefits. First, JuiceFS provides full POSIX compatibility. Second, the performance is separated from capacity. Yes, it's very important. Object store give you a low cost, high reliable, and almost unlimited capacity. And the independent metadata engine and the local or distributed cache give you flexible and scalable performance. Also, because JuiceFS uses a Fuse client, it's easy to deploy and maintain across different Linux kernel and distributions. For Kubernetes, we provide a full CSS driver and also support multiple access methods, including S3 gateway, HDFS, and WebDAV. It helps the different software stack and the different teams use the same data more easily. But one of the biggest difference is multi-cloud support. At first-party cloud product will not give you that. Multi-cloud support give you 2 major benefits. First, you get the same product behavior and the same feature across different clouds. And second, with JuiceFS mirroring, you can copy and distribute your data across clouds and regions. That means your compute resource can read data locally, with lower latency and better efficiency. Uh, Many of our customers already use the feature in for AI inference. Yeah, the performance is always a key question in AI storage, but today I will not go deep into benchmark detail. But in earlier office hour session, we spent time review or ML storage results. So if you care about performance, I suggest you looking at that recording. And ML is useful because it's try to reflect the real AI workloads, not only simple and synthetic tests. What I want to focus on here is a real production use. Open source foundation models such as Minimax, GLM, Mimo use JuiceFS as the shared storage base for their full AI pipeline. And they use it from data cleaning and processing to pre-training to evaluation, post-training, and then to inference. We also support leading AI service such as Hidden for AI, Cerebrain inference engine. Yeah. Oh, for the final part, let's talk about cost. This is something every CTO and infrastructure manager cares about. So we compile monthly cost at the 5 petabytes. We use a public listing price only. We did not include any enterprise discounts. Also, the JuiceFS Cloud number already include the cost of the underlying object storage. We can see the cost gap is very large. JuiceFS Cloud is around 215,000 per month, and AWS Luster is more than 3 times, and the GCP Luster is more than 3.1 million per month. Is about 10 times cost. Azure Luster is close to 2.2 million per month, and the low CI is also 2.6 million. Yeah, as your AI data grows, it's usually that the cost advantage of separating performance from capacity become much more important. You can get performance your CPU needs without paying a huge premium for storage space you may not fully use. That is end of the session. Thank you very much for joining. I hope this talk gave you a clear way to evaluate cloud storage option for AI workloads. Yeah, that's a Q&A session. Any question, you can type in the living room or Excel linking.
Okay, thank you, Surey. So I think in the AI area, there's new challenges for the file system, and I think maybe next time we talk it a topic to about the AI agents. I think if you ever heard about Cloud Code, it's really popular, and if you recent tweets about how to share the memory or knowledge between the agents, right? So a distribute or a low cost or cost efficiency of file system could be ideal for running your AI agents. Maybe this our next topic of the office hour. We actually seeing some of the startups are using our JuiceFS file system as the base maybe the storage layer of their agent operation system, And let's put it that way. There's a new territory for me also. So, yeah, it's exciting times. So, if you guys have any questions about this session or any topic you want to talk about, please comment in the YouTube channel or put in our Slack or other channels over there. And okay, here comes the music.
Yeah, and any topic, if you are interested, you can also submit in. Let us know. Yeah, we are arranging in the next office hour.
It's nice. We got a question from James. I'm gonna put it up on the screen right now. So the question is, what's the most impressive JuiceFS case study you're able to share that demonstrates the economics advantage? So I guess it's for cost reduction, what you're looking for.
I guess it's too many, so we need to think a little bit.
Yeah.
I actually have a very quick example. It's like with the auto driving car. So there's many solutions over there, but the auto driving need training from all the sensors. They generate like tons of data over there, and they need a really high performance as well as cost efficiency solution to store pre-processing, training all those data. And I think like top two self-driving car company are using our solution. I'm not sure if I can get freedom to share their names, but yeah, it's one of the, I think it's very amazing user case over there, because the amount of data is like, I just look at the zeros, it's like thousands of terabytes. That's really a lot of zeros.
Yeah, exactly. That's a good sharing, King. Yeah, I posted a blog over here. We have many blogs like this on our sites, but as King said, self-driving cars. So many cars in the street, and we're collecting the data. Not we are, sorry. The the autonomous self-driving car companies, they are collecting data. And in order to say make the prediction, make the AI more powerful, to be honest, I don't know the frequency. It could be like every second, it could be every millisecond, depending on like what you do, right? So if it is every millisecond, they collect data from all the sensors, and they have like hundreds, thousands, and even more than that cars in the street, and that happens every minute, every day. You can imagine the volume, right? That's why they need cost efficiency in this case for sure. Yeah, quite impressive case study.
Yeah, I have shared another blog post on the screen, and anyone can put it on the stage.
Where did you?
Yeah, I don't have permission.
Okay. Yeah, we will find that. We will show that soon.
Yeah, it's another case study from Lifetime AI. Is they build a global inference engine, and at the beginning they use Amazon EFS to store their AI models, maybe include some small model, big model, but the inference is across region and the cloud provider. So they have to pay a lot of egress fee for the networking, and migrate to JuiceFS and Cloudflare R2 solution. So the Cloudflare R2 is a reduced storage fee and no egress fee, and JuiceFS provide cache locally to improve the performance, and so the total cost cut down the 98%. So the most of it is egress fee. And we also have a lot of case study on our website in the blog, so you can check out.
Okay, so there's another question from James. So this question is about what's the typically the S3 backend of choice for these scenarios, and companies default in other cloud running their own storage. Yeah, so I think it really depends on how many decision factors over there. But we have very big customers which is not using S3, is using App2 and also B2, and storage is from Google GCP or Azure, right? And also they probably build their own object storage is using Mu.io or using Ceph. So, well, I think majority of the customers are not using S3 because using the JuiceFS in total of those, they achieve high performance, and the slight difference between S3 and other methods is not significant in that sense. So, Sri, you want add on that?
Yeah, there's a page in our documentation. Oh yeah, I have shared this page. You can check out all of object storage we supported. It's more than 40 tabs. Yeah, you can see it on the right side. Includes some very popular choice like Amazon S3, GCS, and also include Backblaze R2. Maybe IBM, Oracle, Scaleway is a cloud provider from France, and DigiOcean. Yeah, a lot of object storage, because they almost compatible with S3 particle. So support them is not a hard thing. Yeah, but if you choose the Ceph, we recommend you can combine JuiceFS and the Ceph Rados. Maybe Ceph RGW is not a requirement.
You are very welcome, James. Do you have any other questions?
Yeah, or anybody currently watching, if you have questions, don't be shy, feel free. And if you can't think of any right now, we have our community channels. You can find our site too. We have our GitHub repo. If you're using JuiceFS, the community edition, you can find us in there, like in the discussions, in the issues. Yeah, and if you are looking for somewhere to chat, we recently migrated to Discord, so you can find us on Discord as well. And we also have our LinkedIn page. You can follow our LinkedIn page so that you don't miss the latest news, like the latest updates of different versions of the community edition, the enterprise edition, and everything. Yeah, just so you know, everything is available on our website. So yeah, It's JuiceFS.com. So you're always welcome to join us and look for any information that you need over there.
Yeah, that's right. I think we are, plan to migrate our community channel from Slack to Discord to be more, engaged. Because I think Discord is more, you can do the live streaming, or you can keep all the chat orders to better search, and you can actually. I think some of the bot had been joined up, just to quick. Since we are actually do Q&As live in the channel, so you have a bot, you can ask, or maybe search for existing questions, solutions, case studies over there, and you don't have to actually uh, open the Discord at all. It's like it's AI area, and you can just ask AI about, search this JuiceFS Discord. Just, if they already have this user case before, have these issues before, things like that. So yeah, so we are moving to from Slack to Discord.
That's nice. We get another question from James. Thank you so much. We like active community members like you. So the question is, my initial testing with JuiceFS is around video streaming. Wondering if we have any insights on chunk size for that use case from current users. So in terms of chunk size, I assume you've read our doc. You know that JuiceFS does our own formatting, so we split files into chunks, right? You're not talking about the video chunks, right? Like because in streaming, the videos can be chunked and repackaged as well. I just want to make sure that you're talking about the JuiceFS chunk size before answering it. Let's see if James responds to that.
Yeah, the default block size is 4 megabyte. Is good for most of use case, and the chunk size is as if the block size is 4 megabyte and the chunk size is 6 blocks. Means 64. But the chunk size is a logical combine 6 block. So before you format your volume, you can configure you can customize your block size, maybe change to 1 megabyte or another, and the chunk size is means from 0 to F 6 block size. Yeah. But for video streaming playing, I mean, is the L pattern is sequential rate. So I suppose it's good for JuiceFS. But if you click your process bar, so it means random rate. So maybe the code rate from your object storage, maybe you can fill a store.
Yeah, that's right. I think in this case, the chunk size setting, it's not that important. I think the default 4 megabytes, I think it's good for most of the scenarios. So I think it's very rare to adjust the chunk size for the performance, and unless you have some very special setting like a block device for caching. So again, as Surey mentioned earlier, for the video streaming, we actually have other, I think, options to optimize the read, the sequence read, maybe the read ahead. No, that means when you doing a streaming, it will be sequential reads, and then we can just read ahead to prefetch the the streaming data for you. Yeah, so I think those options we discussed, I think in our documentation, as well as I think we probably have a dedicated office hour about the all this performance training, but mostly there's the cache size and the reader hands and also the buffer size, which essentially increase your parrot the read threads of the mount part of the mount client, right? So yeah, so look at those options and fitting your current visual streaming requirements, and we are happy to help to test all these among options to achieve better performance.
Yeah, yeah, great answers. Yeah, I totally agree. To my knowledge, I worked in video streaming a little bit. That was like years ago. I know the player plays a very important role in that, right? Like player, when that happens, the player downloads the manifest first and then start to download different chunks of the video, not chunks in JuiceFS, but eventually that translates to JuiceFS reading blocks from the object store. So if yeah, please do take a look at our doc and see if any of the features can help you with that. But I do agree that the default size could be great for most use cases, and the player maybe can be tuned as well depending on how it behaves. Normally, it does the prefetch automatically for sure, but yeah, when you're skipping, that could cause a little bit, but yeah, depending on how aggressive you want to do that.
So another way to test your settings is actually using the performance testing tool. We actually have a dedicated uh, uh, a dedicated section for how to performance tuning the JuiceFS system. I think I can put the link here. Yeah, the benchmark and the profiling center. Let me link. Well, if you go to our community edition document site and navigate to the sector called benchmark and profiling, so you can using the benchmark to actually test how it performed, and you can using the maybe third-party tools like FIO to simulate the payload, and then you can tweak different mount options over there to see if this is fit um, uh, uh, for your requirement. But I would say don't be over tuning. So using the default settings for baseline, the whole system, your backend object storage, the metadata, the metadata backend you are using, and then the setup of your client, right? And then you can starting to twist a little bit, like for instance, increase the buffer size. That means there's more concurrent jobs can be run during the read, right? So you just tweak one parameter and rerun the performance. It's kind of like a loop then to just adjust one parameter at a time. And also I think the cache size, there's I think several really important parameters over there you can turn, but don't overturn it because sometimes it just not behave as it expect as it sees. So again, I encourage you to look to take a look of this the documentation on benchmarking and profiling, and to find the right setting for your particular user case. Okay.
Cool. Let's see. Let's give it just maybe one or more 2 minutes, see if any other community members would have more questions. But other than that, please, consider join us over here, juicefs.com/en/community. Yeah, we will update the page to reflect the Discord channel soon, but you can find us, find us on our website, on our GitHub repo, and our chat servers, and that's the best way to kind of keep in touch, right? And I'm not saying this for JuiceFS, but I have a personal habit is that if I like a project, obviously on GitHub, I start it, that's for sure. Then I click the watch button and I pick the releases. So what that does is that, when there's a new release of that software, I get an email, I get notification, so that I don't get all the notifications in that repo. But once a while, I still get reminded, oh, there's this interesting database, there's this interesting storage system that I can use. That's my personal habit. I'm not just saying that for JuiceFS. You're very welcome to do that as well. Cool. So with that said, what do you guys think? I think we have no more questions for today.
Yeah, I think we are good.
Nice. So we're all good right now, and we will see you next time. And thank you so much for joining today. Have a great one.
Yeah,
See you next time. Bye-bye.
See you.